Really looking forward to talking to you today. We were just talking a little bit before we started recording about some of the things that you've done in your career. You've had an incredibly fascinating career as a physician and as a researcher, right? So why don't you just start by introducing yourself to the audience and telling us a little bit about your career trajectory?
So I'm Michael Wool. I am a physician born and raised in California, went to school in California. I've always been very interested in the scientific endeavor. I was in little high school science fairs, and later on in college and in medical school, I was doing research. But in the earliest days, around the 1980s, when I finished my residency, HIV came along. And while I was working as a hospitalist and an intensivist in one of the University of California hospitals in San Francisco, of course, the AIDS epidemic broke out. And there was very little that we could do at that time, but there were not a lot of drugs. And I started working first with the Department of Public Health and with various researchers, and we began to struggle through that whole era of all these individuals who would be HIV positive, nothing to do, lost immunity, very similar to COVID. We intubated a lot of people. Unfortunately, there weren't a lot of medications at that time, so many people died. But eventually, science made its way through to the various medications. They slowly developed. We definitely were part of that evolution. I moved to Los Angeles with my wife, and we started doing research at UCLA. And we were involved in helping to sequence the genome of HIV. And at that time, we had developed a chart which allowed physicians, without complicated, very expensive machinery, to understand the quality of the virus and then to pick medications and then to sequence them to have continued suppression or control of the virus. And this was called the gene chart. And it became pretty prevalent in the world. There were several million copies that were given to sort of disadvantaged countries and communities which didn't have the benefit of these expensive sequencing machines to figure out how to sequence the drugs. So that became pretty famous. And then I was involved in identifying HIV-related brain disease or dementia and help develop medications around that. When COVID came along, I saw a number of patients. In California, actually, we had the highest survival rates of all the nations. And then where I'm at now, Cedars-Sinai, the institution had the best survival rate for COVID patients in the state. So it's been an interesting career. Most recently, I've endeavored to understand ketosis, which is sort of the other side of the energy equation of the body. There's the body actually uses two fuels, either it uses glucose or ketones, and everything we eat either is converted some way, fashion, either to sugar, glucose, or ketones. Ketones come about typically when you're fasting and evolves because of metabolism of fat. So it's been very rewarding. I started a company called Keto 5 about a little over 8 years ago, and we're a science-based company that tries to make ketosis a important factor in health, wellness, and longevity.
I really want to focus on the ketosis aspect of this. I think probably for a lot of people listening, they have this image in their head of the gym bro who's eating the meat and the liver, and that's our picture of what keto is. But I'd love for you to kind of take us on this journey. So I know that ketosis was being studied like back in the 1920s, I think, right?
That's right.
And it was being used to treat epilepsy. So maybe we can kind of start there.
Okay.
And then take us to where we are now with it.
Sure. So actually, the idea that fasting, which is the most common reason why our bodies become ketotic, or blood levels of ketones rise, was actually practiced thousands of years ago by the Greeks and by the Chinese. In ancient records, they were thought to be using fasting as a health benefit. And that was largely lost for obviously thousands of years, yet they persist in various cultures, various religions. They have fasting because it's, quote, cleansing. But it wasn't until about 1915 that a guy named Howland over at Johns Hopkins had figured out that fasting reduced the incidence of epilepsy. And then in 1921, another man by the name of Wild at Mayo Clinics actually figured out that you could eat a certain way to mimic fasting. So the, quote, ketogenic diet came about because of this guy Wildy, and it was his efforts that put ketogenic diets on the map. But if you look at the curve of published information in history, the curve is really, really, really flat until right around 2010. Around 2010, people began to look at the, quote, ketogenic diet because there was an incredible rise in problems associated with high carbohydrate diets or high sugar diets, and even now a better understanding of processing of foods and so on and so forth. But this curve started taking off in terms of researchers being involved, and mainly to mimic, quote, ancestral man, whose actual biochemistry is very similar to a wolf's in terms of the biochemistry of energy production. So at that point, it begins to take off because we are developing diseases related to high carbohydrate consumption, the so-called standard American diet, and the so-called food pyramid, which most people are familiar with. That starts to take off, the investigation, and they begin to identify the fact that ketogenic diet extends beyond control of drug-resistant and refractory epilepsy, but to have a lot of other health benefits. Along with that really was sort of a better understanding of how energy is created in the body. And it wasn't until 1990, actually, that we had identified that mitochondria, the so-called powerhouse of the body, actually had its own DNA and actually is responsible for more than energy production, but for the production of signaling molecules, how cells talk to each other. And basically, with a background in immunology, we began to clearly understand that cells need to talk to each other to get things done in the body. So if an invader comes in, i.e. a virus or a tumor cell or some kind of infection, the body, we're sitting here having a conversation with a microphone, and we obviously have vocabulary, similar language, but the body doesn't have that. So we have to have signals that tell cells what to do. And this whole idea of molecular signaling is a fairly recent phenomenon in worldwide medicine. And it's this signaling that has become incredibly powerful as far as us, A, understanding diseases, and B, understanding and creating therapies around that. And so when you look at ketones, beyond the provision of energy in the so-called gym guy and carnivore diet and whatnot, the presence of ketones as a signaling molecule becomes very critical in terms of health. And this signaling is not absent if your body is generating its energy based on sugar, because sugar is related to insulin, and insulin in certain levels is very healthy for you. In other levels, particularly associated with obesity and high carbohydrate consumption, insulin actually becomes a toxic signaling agent, causing a lot of cellular mayhem.
Can you give us an example of a disease or a condition that would be a result of poor messaging between cells?
If you look at obesity, okay, so what happens is in obesity, you have a giant fat cell. You know, when you're young, you have little cells, but as you mature and get older, and then you put on weight, your cell gets really big. And because it gets really big, it's, if you look at the way physics works, it's a sphere. So it's the radius to the third power, right? So if you're trying to get nutrients and oxygen and get rid of toxins, the ability to go from the surface to the middle of the cell where maybe the nucleus is or the other mitochondria or other organelles within the cell, you don't have that opportunity because the distance to traverse in the sphere is big. So the body gets irritated with this. So in people who have large fat cells, the mitochondria inside get very angry. And they start to elaborate all these inflammatory signals. So you see things like CRP and TNF-alpha and these interleukins and these other sort of strange signaling molecules evolve out of these cells and they become very dangerous. And the primary example is looking at the first 100 patients that were affected by COVID. They were largely obese, obese Chinese people in Wuhan, and they had one of the earliest papers published showed the presence of what is now known as, quote, cytokine storm. And these eruptions of these incredibly dangerous molecules or, you know, deleterious molecules causing, you know, flooding of fluid in the lungs and all this other stuff that's associated is sort of the prime example of dangerous and bad signaling causing bad diseases and bad outcomes.
Okay, so conversely, if people are in ketosis, they have these ketones, these signaling molecules. What conditions can that help to improve? We talked about epilepsy, obviously, is one. And maybe you can go into a little bit why that is so impactful in a condition like that. I know that, you know, you've talked about the brain being an electrical system, essentially. So how do the presence of these ketones in our bodies help to target these conditions, and what can it help?
So the flip side of the coin of ketosis is a discussion that's different than signaling. It's actually a discussion about energetics. And when you're talking about neurologic tissue and our whole body, I mean, here we are in the studio and you've got 120 volts going up to the light, and you flip the switch on, 120 volts goes up and lights the bulb. Well, that is because we have conductive material, copper, with rubber over a plastic insulation. Our bodies have the exact same network. But the difference is we aren't based on copper. We're based in protein, which is electrically conductive. And then around that wire, quote, protein wire, is a fat insulation. And our body operates at 70 millivolts. So you generate a signal here, 70 millivolts goes down the wire here, and it does what it's supposed to do. So what happens in ketones versus glucose is the actual amount of energy, ATP energy, that's produced is about 40% higher in ketones. So when the fidelity of the signal and the power of the signal is better under ketosis. And what's even more interesting is that recent papers have demonstrated that after the age of 60, your brain's ability to actually use glucose as an energy substrate actually declines. So let's take, for instance, you've got someone who walks down the street and they see Homer Simpson. And they say, well, hey, that's Homer Simpson. And so your eyes see this picture, sends back to the occiput where the picture gets understood, which then sends another signal to the front of the head that says, oh, I should say hello to my friend Homer Simpson, and then sends another message to the right side or the left side if you're right-handed and extend your hand and say, hey, Homer, how are you? But what happens in certain disease states where the energetics, so-called hypometabolism or low energy states in the brain, it gets confused and you aren't able to integrate these different systems. So you end up with diseases like Giles-de Tourette syndrome, where someone will be talking to a parking meter and saying, hi, this is my friend Homer Simpson, when it's really a parking meter. So I think this is something that you see in terms of global energy and that focal parts of the brain that don't receive the energy portend to that disease, whether it's Parkinson's, Alzheimer's, ALS, multiple sclerosis. These are, and even COVID, long COVID with brain fog. These complicated scans of the brain, which difficult to get into, but nonetheless can show focal areas where there's decreased metabolism in that area. And so you will have problems of smooth motion or problems of memory or problems of smell. And in fact, COVID's perfect because the virus is a neurotropic virus that goes down the olfactory nerve to get into the brain. And so you lose your sense of smell. So you can tell that if you disrupt the function on that tract, wherever that tract is controlling has the problem.
That's fascinating. I was just thinking of when I got COVID, and for me, I did have some of the respiratory symptoms, but then I had really primarily cognitive symptoms for weeks. I mean, like dizziness and brain fog and some vision stuff. And it was pretty unnerving because
I'm sure it was.
Anything neurological, you're just like, what is happening? And seemed like nobody really knew like what the treatment was for that at the time and why it was really happening.
Well, the treatment is still pretty interesting, scientifically. First of all, in terms of inhibiting the virus, you've got drugs like Paxlovid, which is a dual protease inhibitor. And the problem with that drug is that it kills the virus great in the circulation. But the molecules are so big, they don't get into the brain really easily. So you get people who take Paxlovid and the virus disappears, but it may actually live in this protected barrier, the blood-brain barrier. And as soon as the drug pressure is off, the virus reemerges and
that happened to
reinfects
me.
the patient.
I got rebound. After taking Paxlovid.
So Paxlovid, it's a great drug if the virus is in the blood circulation, but the virus reemerges from the protected space. And in the protected space, we're having challenges of long COVID because of the persistence of these metabolic derangements of nerve cells and maybe accumulation of toxins and this other stuff. So we believe that elevated ketosis may supplement this energy deficit and improve sort of the conduction of signal from point A to point B to your brain to make that function happen. And we see that in various parts of literature that these areas of, quote, hypometabolism or low energy that get supplemented with ketones actually results in improvement of symptomology and improvement of function. So I think that's where the science is headed. So we look at the long-term value of the fact that we have ignored this other portion of our entire energy system. Ketosis becomes a critical element to examine in terms of the benefits in all these not newer disorders, but all these disorders, which could benefit by having the energy supplemented when our system is being driven by sugar.
Totally. It's fascinating. I know that ketosis can also be useful for things like weight management, body composition, inflammation. So I'd love to talk about first the diet aspect of it, and then the exogenous ketones aspect of it? And do you have to do both? Can you do one or the other? How do they work together or separately?
So the ketogenic diet became adopted, as I said earlier, from the history of trying to seek a better metabolic pattern in your body.
Mm-hmm.
And it became in favor, and based on the information of the epilepsy trials, that fat-heavy diet, 70 to 80% fat, 20 to 30% protein, and 5% or less of carbs, became the mantra of the ketogenic diet. But as it got effectuated into the general population, people said, I'm not going to eat all this kind of fat. I mean, what's going on here? And if you look back at times when Dave Asprey was figuring out bulletproof coffee and all this other stuff, this was an effort to make fat more palatable. At the same time, Ansel Keys, back in the 60s, had produced his so-called 7-country study, which said that animal fat was bad and it was dangerous. And then a bunch of people completely refuted that. So the diet had a lot of complexities to it. Public acceptance of the fact that I've got to eat all this fat. B, I'm not used to eating all this fat. So it's like, am I going to harm myself? And so compliance is difficult. And in fact, I was just at the neuro-keto meetings at the University of California, San Diego, where I was talking to nutritionists and dietitians that take care of epileptic children. And they said that even in these kids that have really sort of severe epilepsy, they can only get the kids to be about 40% compliant to ketogenic diet. Either A, because carbs are much more palatable and enjoyable. And they like their candy and they like their, pizza. So that became a challenge. So there are ways to be vegan keto. There are ways to do keto in a bunch of different ways. And then also, as time went on, we became to understand that maybe you don't need to be keto all the time. Maybe we should be like wild animals, keto, maybe 40, 60, 80% of the time, and being driven by sugar the other part of the time, and having this so-called metabolic flexibility. And that's where we are today, that we do not have to be draconian. And in fact, the Atkins diet, which is, a heavy protein diet, can get you to the same degree. I think it's more the low carb idea today. Now, what does it do for body morphology and shape and distribution? Absolutely. And when you're looking at situations where people are on ketosis, or if I'm recommending a ketogenic diet or I'm recommending exogenous ketones, I tell patients you really need to do some sort of exercise. Otherwise, in this so-called ketogenic process, you may lose more muscle mass, which is called sarcopenia. And by doing some weight-bearing exercises, you'll preserve your muscle mass and making sure you're eating adequate amounts of protein. Now, how does that all fit into the so-called realm of the latest craze, which is the semaglutides, Ozempic, Wegovy, Mounjaro? There's a lot of facets to really sort of understanding this. The simple fact is people think, oh, I take this shot and I don't eat. Okay. And I lose weight. And
are they going into ketosis if they're not eating?
That's exactly right.
Okay.
And so some of the part of this semaglutide trend is that people are entering into ketosis, which then begs the question, can I do ketosis with semaglutides? And there's a lot of physicians and papers and anecdotal cases of them using it together. And there may be, time will tell, And science will tell whether or not we can actually use them in combination, either A, to lower the dose of semaglutides, because semaglutide is the adverse event profile is potentially dose related. Now, there are other things where it's idiopathic, where it just comes about, but many of the side effects, the nausea, the vomiting, because it's gastroparesis, right? It's paralyzing your stomach so that you don't feel like eating.
Yeah.
But at the same time, when you don't eat, you raise your ketosis levels. So maybe both ketosis and the reduction of the, quote, hunger hormone, ghrelin, occurs in both states. So it's logical to assume that using both may be synergistic. It may be of great benefit. It may lower the cost burden, and it may lower the side effect profile. I think time will tell. Our organization is busy trying to explore the answer to that question from a scientific basis.
So fascinating.
It is. It really is fascinating. And it's something that people can relate to.
Yeah.
It's not like you have some rare disorder that no one can really relate to. It's something that is near and dear to everybody, especially since 70% of the population is overweight and 40% of the population is obese.
But I'm just wondering, I feel like keto has been so over marketed, and you can go into Erewhon or any grocery store and you see keto cereal, and it's loaded with carbs and maybe really high fat as well. But I feel like I always see these products that say keto this, keto that, and then it doesn't seem to really fit the profile of what true keto, what a true ketogenic diet is.
Well, American marketing is American marketing, right?
Yeah.
I mean, they're there to take advantage of this trend. And so the consumer needs to be very cognizant of this. I mean, I'm sure they do. I mean, I think that back in the early days when the FDA chairman made us put the nutritional label on there, and more people read labels. So education becomes important. And one of the things that we do see in the office is that patients come in with the nutritional panel and they don't understand net carbs, fiber carbs, sugar carbs, and the way it's described, right? So I think that in itself, understanding that is important. But one thing that's very important to understand is that our understanding of fats and its contribution to, quote, heart disease is really up in the air. And that looking at how the data that was constructed for the cholesterol medications is of paramount importance. The American public understands that our idea of fat back in 1960 being dangerous for you is not the same idea of fat today. And that there are really good fats, and that these fats have not been shown to cause coronary artery disease or increase stroke rates. And even at the time, we have to understand that the brain is 92% cholesterol. So if you lower the cholesterol, you're lowering the insulation around the wires that drive your brain. So if the signal bleeds out because the insulation is not right, then you're having, quote, disorders of cognition, right? And if you look at every cholesterol medication package insert, which is required by FDA, you'll see that prolonged use of this medication may result in problems of memory. Well, what's that about, right? So if you look at brains that have been on long-term cholesterol medications, you find that maybe the lining is shrunk a little bit.
Wow.
And these are ongoing trials.
Okay, so is a ketogenic diet appropriate for everybody?
No.
Okay.
A ketogenic diet is not appropriate for everybody.
Okay.
The biggest warning is for type 1 insulin-dependent diabetics, because the chances of going into ketoacidosis are not small.
Mm-hmm. But
that being said, really type 1 diabetics are fairly uncommon. And the number of people in a advanced society, in a first world country, ketoacidosis is fairly uncommon.
Mm-hmm.
And certain kinds of medications that people take would be unadvisable to have a strong ketogenic diet. It can be done.
Mm-hmm.
Taking exogenous ketones, same thing. We believe that exogenous ketones have the value of not having to have the subscription to this sort of diet that's so draconian, or some people fear the fat. You can drink ketones and get the same level of ketosis without having to adhere to the diet. And I think that's a very important concept to bring about, because we know that now the molecular structure of the ketones that we make come in a right-handed and a left-handed version. And one type of the molecule will attach to heart muscle and skeletal muscle, and the other one will attach to brain cells. Wow. This is the latest.
It crosses the blood-brain barrier.
Well, the molecules all cross because ketones are incredibly tiny.
Oh, okay.
If you measure the amount of ketones in your blood, it's equivalent to the amount in your brain. So by drinking our ketones, you can raise the ketosis level pretty much in about 40 minutes. You don't have to spend 3 days trying to get into ketosis with a diet. You can get there. And the understanding that this level of ketosis may produce signaling, and this signaling may be very, very important as we develop the science. Exogenous ketones have a great future in terms of its value in various aspects of health and certain disorders.
What are some of the desired health outcomes of incorporating exogenous ketones into one's diet?
Well, first of all, exogenous ketones are probably a lot more convenient. And our products are structured in a way that it's more or less bioequivalent to what your body composition of ketones is. So our ketone BHB, beta-hydroxybutyrate, as natural as your body, is the same molecule your liver makes. So it's not a foreign synthetic. It's the actual structure is identical, bioidentical to what your body makes. Secondly, because of that, and because it can be absorbed from the gastrointestinal tract in a drink really quickly, we can raise you to the desired ketone and level. So over the last 5 or 10 years, we began to understand what varying levels of ketosis do. So Steve Finney, who was a guy at a couple classes ahead of me, had figured out what it was called nutritional ketosis. At 0.5 millimolar concentration in the blood of beta-hydroxybutyrate, you have what is called nutritional ketosis, which is where you're burning your fat. But it's been determined now that higher levels, 1.5, 2.5, 5, et cetera, you get to the levels where you're starting to modulate inflammation, reactive species, improving nerve conduction, all of these things that have been studied now over the last 10 years and made a huge difference in terms of our understanding of normal biochemistry, physiology, et cetera. And we could take advantage of that. And I think that in terms of the future of exogenous ketosis, that's really where we want to be. We want to be able to adjust the level of ketosis to the needs of the physiology of the body.
And how does one determine, though, what their needs are?
Well, I think this is a field that we're beginning to understand. And where we are now is we can have blood meters that measure the amount of ketones and measure the amount of sugar, glucose. We can measure them episodically. And then some companies have provided machines now you can measure continuous glucose. And just around the corner is the new FDA device that's coming out, which is measuring continuous ketone. And Abbott Labs is going to come out with the first FDA-approved continuous ketone. So now what are we going to have? We're going to have a continuous readout of what we eat, what we do, how we exercise, and this whole idea of the, quote, wearables becomes really exciting.
Yeah.
So now your Apple Watch looking at oxygenation, heart rate, EKG, your Oura Ring, these things begin to correlate changes of these physiologic parameters that they can measure against what we do to our body. And I think the next generation, my daughter, who wears 4 devices and is a Frisbee pro, carefully looks at what she eats and how she exercises to see what happens when we have these, quote, perturbations of our, whether it's something we eat, we drink, or how we exercise to optimize ourselves. And that's where we're going with ketosis.
Yeah, it's so interesting. Everybody has the ability to become their own kind of biohacker. And I know biohacking gets kind of a bad rap, but we have all of these tools now. And it's such an amazing time, I think, to be able to have that data and to make modifications and see what changes that makes in that data and in how you feel and your health and all of that. I'm sure that you're very excited for where it's going to continue to go, because it seems like everything is changing so quickly with all this technology.
That's right. Processor speed has really made our ability to have real-time feedback as to what we're doing with ourselves. And really, at the end of the day, really, we are trying to answer these questions. Where did I come from? Where am I going? And what am I doing? And on a real-time basis, the aggregation of this massive data will be using, whether it's artificial intelligence. I mean, we can find the subtleties, which may end up to be not so subtle as time goes on, that really, the kinds of foods we eat, which is why we're seeing these choices in the supermarket, why we're seeing these scientists get up on the world stage and saying, maybe we ought to re-examine this, and maybe we ought to have a different viewpoint of that, because the data is beginning to reveal this, that, or the other thing. And this whole idea of artificial intelligence and computer speed and real-time sensors and biosensors, and I think biohacking is actually a really important science, in all honesty.
Where does something like intermittent fasting come into all of this?
Intermittent fasting is really the first big attempt of man, or certainly in America, to mimic the wild animal and to drive that metabolic flexibility, to drive your body into ketosis. The average American will live 92% of its life driven by sugar and 8% in ketosis.
Wow.
If you look at wild wolves or coyotes, not the ones here in central LA, but the ones out in the mountain or Alaska, they live a significantly higher portion of their lives in ketosis. They actually naturally have intermittent fasting because they have to hunt. So they're eating every 2 to 5 days. We're drive up, roll the window down, and somebody throws a burger, fries, and Coke in there.
And eat 6 times a day.
Right.
So you don't get hungry.
Right. So the idea of intermittent fasting came about to try and mimic ancestral man and wild animals to get that ketosis level higher. So intermittent fasting plus exogenous ketones is even better. So I think that the eating schedules of 8-16 promote the formation of ketone bodies, probably not as high as you could get by drinking a ketone drink. Drinking a packet of exogenous will immediately drive you into ketosis, similar to the levels that you would see in an animal who'd been fasting for a while.
Interesting. I do have one question about this concept of ancestral man. I mean, ancestral man didn't live very long, right? So is that just because there weren't medications, there was disease? It's just a separate thing?
You're right. Okay, so centurions did exist in ancient Egypt.
Wow.
The average person lived to like 40.
Right.
But what did they die of? They died of infectious disease.
No antibiotics.
No antibiotics. They died of wars and things like that. So if there's an interesting sort of a series of experiments, but basically, if you take a wild animal at birth and follow them out to death, and you do a full autopsy on them, and you take out the ones that died of infectious disease, you take out the ones that died of being predated, you take out the ones that died in a forest fire or fell off a cliff, and you look at the remaining carcasses and look at the autopsy, you find that 90% of them had no evidence of disease.
Wow.
That 10% of them had cancer, asthma, diabetes, inflammatory bowel disease, rheumatoid arthritis. But that's only 10%. If you go to an American mortuary, 90% of Americans die of disease and 10% live and die of natural causes. So completely the opposite.
Yeah.
Right? Yet the percentage of time that we live in ketosis compared to the percentage time the wild animals live in ketosis definitely shows that there must be an inverse correlation. Can you do a randomized placebo-controlled double-blind study on that? The answer is no.
Fascinating. Well, I learned so much today. Thank you so much for coming on and sharing all of that with us. Tell everybody where they can find you.
Our company is called Keto 5, and you can find us at keto5, the number 5.com. And you can always write to me on at mwool@keto5.com, and I'll be happy to answer your questions. And then thanks so much for having me. It's been a joy. And
thank you. Likewise. Thank you.